Okay, good morning, for Science 1. Nice to meet everyone here again. Hope everyone's doing fine out there now, to start Tuesday morning, your first lesson for today lah. Okay, 8:30 we start our first lesson here. All right. First things so I don't want to waste any more time, so I want to continue our lesson. So I start sharing the paper with you now. Okay, I hope you have the paper in front of you. Okay, you should have the paper in front of you lah, by now. Okay, we are on free fall motion. Okay, free fall motion. So it's somewhere here, right? We stop at this example in our last lesson. Here, Marcus, correct? This is one, right?
Yeah.
Okay. So now, what is free fall? When I call your name, can you answer? What is free fall now? Aislinn Lim, what is free fall? Free fall is what, Aislinn? Aislinn, can you hear me or not? Free fall is what? Huh?
An object falls with an acceleration due to gravity is said to be free fall.
Is it enough with that answer? Fall with acceleration due to gravity? You want to add any more things or not, Aislinn?
Wait.
Your answer is correct. Yes, one more.
Without other resistance.
Yes, correct. So that will be complete now, your answer now. Okay, thank you. So meaning that object falling under the acceleration due to gravity, and also we have to say without any external resistance. For example, like air resistance. Okay. Next, last lesson we learned one very important formula. Okay, what was the formula? The very important formula, Charisma. Can you tell me the formula you learned last lesson? Charisma.
Square root of 2s over g.
Yeah, square root of 2s over g. Charisma, this formula is for what? For us to calculate what?
The free fall.
Free fall.
The acceleration.
To find the acceleration.
Yeah.
The formula is for us to calculate what actually, Charisma?
Acceleration.
To find acceleration. Marcus, do you agree or not? Charisma say to find acceleration.
I'm not sure.
You're not sure. Lai Hongzhi, the formula is for what actually? Yes, to find the time. Okay, yes, correct. Lim Leong Chen. Actually, to find the falling time. You see the title of the formula is T to find the time. Okay, Okay, now we look at example 2. Okay, we go straight to example 2. A trolley moving with uniform velocity 5 on a table. A trolley moving, you see here, the trolley moving like this. Velocity is 5 meters per second. Okay, after that, the height of the table 1.25. So the height. So now the question is, the trolley will drop to the floor, follow this parabolic path, right? First question, calculate the time to reach the floor. To find the time, so I think nothing new lah. Just use the formula 2s over g. S is the height 1.25. Gravity is 10. If not given 9.81, so we use a gravity value 10. So you get 0.5 seconds. So meaning that this trolley will take 0.5 seconds to reach the floor here. Then how to find the values of x later on? We know the time already, 0.5 seconds. So then what is the distance x here? How to find the distance x? Okay, very simple. Normally use common sense formula to find distance. You just take the velocity, the speed, multiply the time. That's all. Okay. Straightforward, simple. Okay. To find the distance travel, you take the horizontal velocity, horizontal speed, multiply the time taken. So you get velocity 5 times 0.5, so it's 2.5 meter lah. So this distance is 2.5 meter. Okay, so that's all now. Understand? All right, now one more subtopic we want to finish it very fast. Weight. Okay, why we study weight here? Because weight is something to do with the gravity. Okay, so every time when you are standing on a weighing machine, weighing scale, right? You stand on the weighing scale, then you see the reading, you put there 49 kilogram. Or you are bigger size, you stand on the weighing scale, it come out 68 kilogram. Now you see now, all the weighing scale given you the reading in kilogram. That one was actually the mass. It's not the weight, it's a mass. Because mass is in kilogram. But now we are studying weight. Okay, now we already know the meaning. Weight is, okay, highlight. Weight is the gravitational force exerted on it. So meaning that now, if people ask you what is the meaning of weight, so you must say how much force acted on an object by the gravity. That is called weight, Okay, so please highlight the definition of weight now. Weight of an object is a gravitational force exerted on it. Meaning that weight mass related to the gravity. Okay, but we make it a stand like this lah. The scientists already say, right? 1 kg you have 10 Newton or 9.81 Newton. Every single 1 kilogram you will receive, we say 10 Newton of pulling force on you. Okay, that's why the formula to find weight is W equal to mg. Weight equal to the mass multiply the gravity. You take the mass times the gravity, so you will get your weight. So SI unit for weight is Newton, so it's different now. Mass is in kilogram. Weight must be in Newton. If next time your teacher asks you what is your weight, you must say, if you are 45 kg, you must say 450 Newton. Weight must be given in the units of Newton, not kilogram. Kilogram is a mass actually, not the weight. So for mass, you can change to weight by just multiply 10 Newton. Or to be more accurate, is 9.81 Newton per kg, correct not? Yeah, okay, now look at this example. An astronaut landed on the moon, brought back a stone. On the moon's surface, the stone has a weight only 8 Newton. You see, very light. On the moon, the stone only weight 8 Newton. On weighing the stone on Earth, the weight become 50 Newton. Okay, why so much different now? Why so much different? On the moon, the stone is only 8 Newton, but when come back to the Earth, it becomes 50 Newton.
The gravity on the moon
yes,
is...
correct, thank you. It's because the gravity make it different. The gravity on Earth is 9.81, or we say 10 Newton per kg. But on the moon, what is the values of gravity on the moon? Anyone remember or not? What is the values of gravity on the moon? Ryan Teo. Okay, someone give the answer. Yes, Jiong, very good. Jiong say 1.6. Yes, correct. On the moon, the gravity is only 1.6 Newton per kg. On Earth, 9.81 is 6 times heavier, roughly it's about 6 times lah. Okay. So now in this question, is given the value acceleration. Acceleration due to gravity is 9.81. Yeah, just one. Boleh. Bawa sini sekejap. Okay, so if given the acceleration due to gravity is 9.81, so we have to use 9.81 instead of 10. Okay, first find the mass of the stone on Earth. How to find the mass? So to find the mass, only one formula you learn, use this formula lah. W equal to mg. W 50 Newton. When come back to the Earth, the weight is 50 Newton. You find the mass. Gravity, you take 9.81. It's given in the question 9.81, so use that. So the mass is 5.097 kilogram. This is the mass of the stone. Okay. All right. Okay, Yan, understand all? Okay, now P, find the acceleration to the gravity for moon. So you are supposed to find what is the gravity on the moon. So what we do, use the same formula. W equal to mg. But now on the moon, W, the weight is 8 Newton. Mass 5.09. Okay, well, now I want to ask you, why on the moon you can also use a mass as 5.097? Why you can just copy this mass and put it here? Why? Why you can do that? Why we can do that?
Because the mass never change.
Yes, correct. The mass will never change one. The mass on the Earth and the mass on the moon remains the same. You remember now, mass will never change in whatever situation, whatever condition, it won't change one. The one will change is weight. Weight affected by gravity. Okay, yes, correct, Lim. Okay, so you get this answer lah. So gravity on the moon is only 1.57 meter per second square. Very little. Okay, okay, one moment. Siapa ni budak? Tingkatan berapa? Kalau dia tulis tarik ini, hari ini dia kena pergi tau. Okay. Okay, sama-sama. Okay, all right. I think we have finished this subtopic already. So now is the time for you to answer all the questions. Okay, let's
up.
Yes, Marcus, you got anything to ask?
I just thought of something. The gravitational pull weakens as you leave, move further apart from the core of the Earth.
Yeah.
So do we need to take in account of that when we are calculating free fall? The decrease.
That different is within 100, 200 meters distance. It won't be so significant.
Okay.
The decrease of the gravity will not be so significant unless it's like 100, 200 kilometers like that. Then you can see the effect.
Okay.
Marcus? If the question given the distance or the height is about 100, a few hundred meters, it won't be so significant the gravity. So you can still take 9.81 or you take 10.
Okay.
Okay. All right. Now, first question. Which velocity time graph show the object velocity varies? Okay, which graph is correct? On fall freely. Show your answer. Please share your answer here. Which graph is correct? Velocity time graph show how the object velocity varies. Free falling. Okay, which graph is correct? Okay, 1, 2, 3. 3 answers already. I see. Jiang say 1C. Choi Si Kai also 1C. Ong Jiao Hao, Wang Ong Jian Hao 1C. Everyone says C. Okay, correct. The answer is C lah. It must be a straight line going up with constant gradient. Constant gradient show that the acceleration is constant lah. Because gradient in the graph is acceleration 9.81. So it must be a straight line with a constant gradient. Yes, Charisma, you are right. Okay, number 2. Which diagram show the graph velocity time for rock fall freely on the Earth and on the Moon? 2 different places. So one graph show fall freely on the Earth. Another one show fall freely on the Moon. They must be different. So which graph is correct? Okay, now 1, 2, 3. 3. Choi Si Kai, Liu Jiajin, Jiang, Ong Jian Hao, and Marcus said D. So many of you said D. The answer D, yes, correct. Why D? Why? Why you all choose D? Because on Earth, right, The gradient must be bigger because gravity on Earth is 9.81. It must be bigger gradient lah. Of course, I all start from 0 lah. Okay, Earth the gradient is representing the acceleration gravity, right? So Earth gradient bigger. Moon, the gradient must be smaller lah because the gravity is only 1.67. So mean the gradient smaller. This one gradient bigger. Understand? Okay, number 3. This one. This one. Diagram show a coin. Cannot see clearly lah, but inside the vacuum cylinder you have coin. You have marbles, and also you have a dry leaf, right? 3 different things being released at the same time in the vacuum cylinder. Okay, last lesson I told you that if they are falling down on vacuum, right? So they will reach the base at the same time. This one is a special things about free fall. When they are falling down in the vacuum cylinder, right? No air resistance. So when no air resistance, so meaning that they will experience the same acceleration, the gravity 9.81. This is the reason why the 3 objects, regardless their size, their mass, right? They will fall with the same speed, fall down with the same speed. Okay, class, bear in your mind now. This condition only can happen when free fall, means falling in the vacuum. Okay. But in the real situations, let's say falling down in the air, right? Let's say you drop the 3 things outside your house. Definitely you don't see this thing happen. You will notice maybe the marble drop faster. Second, followed by the coin. Maybe the dry leaf because very light and the surface area so big. So it will take longer time to reach the ground. That will be the real situation, When they are falling down in the air, it's different from they are falling down in the vacuum. This question is asking about falling down in the vacuum. So all same lah. Okay, understand? Any question here? Jiajin, anything to ask?
Nothing, sir.
Nothing. Okay. Hujaro? Anything to ask or no? Hujaro? Hujaro?
No,
No?
sir.
No, sir. No, sir. Anything? No, sir. No, sir. Okay, now, Jared, what about you, Jared? Can I understand, Jared?
Understand.
Understand. Okay, good now, Joel, our Mr. Joel Lim there. What happened to this point now? What happened to Joel? Joel, okay?
Okay. Okay.
Okay, Okay, number 4 now. The answer gravity lah. A ball fall freely near the surface of Earth. The one will remain constant is acceleration lah. Why is acceleration? Because gravity. Gravity actually is an acceleration. No, that's why we say gravitational acceleration. Actually, the gravity 9.81 meter per second square is the acceleration. Okay. Okay, Okay, number 6. So which one is the answer? Joel. I want to test Joel, see whether he fully wake up already or not. Joel, which property of body affected by change in gravitational field?
The weight.
Yes, correct. Okay, you are fully wake up lah, like that. Weight affected by gravity. Okay, that's correct. What sorry tertekan John, what is it? Okay, number 6. Which of the following statement is true? Okay, which answer is correct? Which one is true? Which one is true? Number 6, D. Okay, who give the answer? Choi, Kai, Marcus. Yes, the answer is D lah. All right, so just check the answer. Weight depends on acceleration due to the gravity. So D is correct lah. This is the only answer correct now. D. Okay, number 7. We go direct because not so difficult lah. A steel ball fall from a high building and take 4 seconds to reach the ground. Calculate the height of the building. So what formula to use here? You are supposed to find the height. Okay, now got two different versions of answer. Jiang Zhensi give answer A. And these are, now sorry, she say. Zhong Wenhon say B. Jiang Zhensi changed her mind, now go back to B. Okay, and more B coming out now. Ong Jian Hao. Yeah, it's true that Jiang you sasat. Sometimes you sasat, no Jiang. Okay, the answer is B. Okay, all right. So I think don't need to explain so much. You also see the answer, you can understand. Okay, so just apply the formula. Time equal to square root 2s over gravity. So the time taken 4 seconds, just put in, you find the s lah. Gravity is 10. So open the square root sign over here, you square the 4 becomes 16. Okay, 2, 10 cancel, you get 5. So 80 lah. So 80 meters. That's the answer. Okay. So the height of the building is 80 meters. Okay. Okay. Next question. Straight away see the answer. Object dropped from a height 50 meters. Calculate the time taken. Just substitute in this formula. Direct, you can answer. 3.2 seconds. 2s over g. So you get 3.2 seconds. So okay, quite simple calculation. Okay, number 9. Structure question. This was an SPM question actually. Okay, let's see what happened in this question. Okay, ready or not, class? Figure A. So got two figures here. A is here. Shows a feather. This is a feather, very light, thick surface area. Water droplets is here, falling from the same height. The mass of the feather and the water droplets same, meaning that in terms of mass are no different. The water and the feather has the same mass. The only difference is the surface area. This one big, this one smaller. Okay. This question say they are falling down like this, meaning that they will encounter with air resistance. They are not falling down in vacuum. So definitely you will see the water drop faster compared to the feather. Feather slower, common sense, no? So you see the graph. The water droplets, you can see the velocity. This is velocity, right? Velocity keep on increase, get higher, and then after that becomes steady velocity. Whereas a feather, you see the velocity increases at first same, but after that the velocity increases less. It still increase but it's getting the increments of the velocity of feather is less So eventually the feather achieves steady velocity, but the velocity is lower compared to the water. Means the water flow faster. Eventually the final velocity. So the water drop faster compared to the leaf, not leaf, the feather. Okay. So understand the graph, Okay, let's go to the question. What the question asks. Okay, now see the answer straight away now. One force acting on the feather and the water. Actually, there are two forces. Air friction is considered a force, air frictional force. Another one is gravitational pulling force. So there are two forces acting on the object. One is a gravitational pulling force, pull them down. Another one is because they are in contact with the air, so they have air resistance or air frictional force. Or we say air frictional. Frictional is considered a type of force, so you know. Beside the gravitational pulling force, and using the figure, compare the surface area of the feather, for so bigger than the water. This is common sense only. Okay. So far, you look at the SPM question, it's not so difficult one. Okay, now using the graph, compare the changes in the velocity. This one a little bit difficult. Okay, how to give answer? Compare the changes in the velocity of feather and the water. Okay, how you answer? By looking at the graph, can you give answer? They ask you to compare, compare changes in the velocity.
The increment of velocity of the water droplet is more than the feather.
Yes, correct. Very good. So you can see now, the velocity actually of the water getting higher, more is higher compared to the feather, right? So the answer will be like something like this lah. Initially, it was the same. You see the graph, both of them initially same velocity. After that, velocity of water droplet are not decreased. So please cancel. This one cancel. This one not correct. The velocity never decrease. Actually, velocity keep increasing. Velocity of water droplets. How to give the answer? Velocity of water droplets. Cancel this one. Velocity of water droplets is higher than the velocity of feather. So please change the answer now. Velocity of water droplets, the water droplets, right? The velocity. Maybe I give an answer. You're right now. Velocity water droplet increases with higher rate compare. I type it here, but no place to type now with higher. Because the question asks for change in the velocity. We say change in the velocity, Okay, so like this, I type it up lah. Never mind a little bit. I type here lah, so that you can see. Okay, velocity water droplet increases in higher rate compare with feather. Okay. Okay, like that. Okay, get the answer or not? Velocity water droplet increases in higher rate compare with the feather. Okay, that should be the better answer. The velocity of the water actually increases in a higher rate. Correct not? 4 comments here. Joel say different things. Lim say what? Velocity of water droplet increases faster. Yes, this one can be accepted. Lim, you are right. Jiang, doesn't feather velocity increase in higher rate? Jiang, you think carefully. Is it the feather velocity increase higher rate? Joel say no already. Water. Joel say water increase more. Yes, correct. Joel, you are right. Actually, the water velocity increases faster, increases more compared to the feather, right? So we say velocity of water droplet increases in higher rate compared to the velocity of the feather. John, understand? Okay, taken down the answer already, everyone? Okay, welcome, John. Jared, got it? Jared?
Copy already.
Copy already, Copy, you understand or not? Jared? Understand. Okay, good The other student all quiet, only I don't know this they are listening one or not. Chua Jia Wen, understand?
Yes, sir.
Okay, good Chua Jia Wen. Go Si Chi, understand?
Yes, sir.
Okay, thank you. I just called name only because I don't know you all, actually still don't know you. Ho Wei Ren. Okay, understand?
Yes, sir.
Ho, I think I know you already. You came here, you came to my room the other day, correct not?
Yes.
I remember you Ho Wei Ren. Those who came to school to find me one, I can remember. Hu Jia Rou, understand?
Yes, sir.
Can And Ong Ching Yong, okay, understand? Ng Ching Yong no sound. What happened to this boy now? Ng Ching Yong. Okay, can you understand?
Yes, sir.
Can. Okay. Lim Si Yi. Okay. Lim Si Yi. Okay lah. Okay. Understand? Cancer. Sarah. Okay. Sarah Ting. Okay. Understand?
Yes, sir.
Sarah, I think I know you lah. Okay. There are few of them I know one since because always see you walking around the school. I know lah. Andrew. Okay. Understand? Andrew Tay.
Yes, sir. Excuse me. Yes, sir.
Andrew, I know lah. This boy, I know him lah. He very, the whole school, every corner can see him one. Okay, D. Using the answer, state the relationship. Okay, this one common sense. Relationship between the surface area and final velocity. The larger the surface area, the lower the final velocity. Okay, correct not? You can see the feather, bigger surface area. Then the final velocity of the feather is lower. So we say the larger the surface area, the lower the final velocity. Okay, this one done. Okay. Nothing much to explain also lah. Your guy can understand one. Okay, last. The feather and the water droplets are dropped in the vacuum now. Now we drop them in the vacuum. Sketch the velocity time graph. Okay, how do you think? Just now the graph was not falling in vacuum. So now they say these two things, we release them in a vacuum. The water and also the feather. Release them in the vacuum now. Okay. How should be the graph look like? Shara, can you explain? What graph are you supposed to expect? Expecting what graph?
Directly proportionate.
Directly proportional. For both of them, same graph or different graph?
Same.
Yes. What is the gradient of the graph, Shara? It's a directly proportional graph lah for both lah. Then one last question I'm going to ask: what is the gradient of the graph? Now got someone keep answer already. Marcus say 1. Marcus say gradient is 1. You know, I don't know how you get 1. Anyone can answer the question. What should be the gradient of the graph? Another student give answer. Ng Ching Yong say x equal to y. No. Hoveren say constant. Of course it's now I wait. Finally I saw got one student give the correct answer. But 2 students give the answer. 3 students give the correct answer. The gradient must be 9.8, 9.81 or 9.8. The gradient must equal to the gravity. Eslin correct. Liu Jiajin correct. Yap Xiao En also correct. Means you know the graph gradient. The gradient is representing the acceleration so the acceleration must be equal to 9.81. That's why you get a graph like that. Okay, now this is a graph lah. So you draw a line, actually same one both of them, but I use different color same acceleration. So to get 9.81, so I put here 1, here 9.81. So in that case, the gradient will become 9.81. So I just simply label here 9.81. Here is 1. So when you calculate the gradient, you will get 9.81. Same as the gravity lah. Okay, so please take down the graph now. Hey, draw properly lah. When you pass up your paper some do it very nicely done your work. Some very messy, you know. Very messy. Your handwriting very messy lah. Some lah I say. Okay. So okay, finish. And true. Understand the answer or not? Joshua, do you understand?
Yes, sir. Understand.
Joshua, when you want to pass up your folder, you haven't passed up your work.
The first time I pass up, you never mark one. I passed up the second chapter also, but didn't mark.
Yeah, because first time you are not supposed to pass up chapter 2, That's why
I pass up again.
You pass up again.
Okay. Okay.
Like Choi this morning, I marked his because he passed up. Okay, when I came to my room, I saw the file is on my table, so I mark his lah. Choi, okay, everything done, Choi?
Thank you, teacher.
Okay. Okay, okay, so this one settled. Another question now, also SPM question. Figure show a skydiver jumping out of a plane at a certain height. You see the aeroplane, so this man jump out now. So he's using parachute, right? Figure shows a graph velocity time for the motion of the skydiver at position STUVW, different position. Okay, now you look at the graph. Now the graph is like that. So you notice that this is velocity, this is time. So right after the man jump out from the aeroplane, you see the velocity getting higher, velocity getting faster, then suddenly the velocity suddenly drop, you know. Then finally the velocity become constant. Okay, so you know what happened, right? I think initially when it jump out from the aeroplanes, so sure it's getting faster and faster one. So that's why you see the velocity increasing now, keep on increasing, and finally at this point the velocity start to decline. You see the velocity slow down until finally the velocity becomes stable at only 10, velocity only 10. So understand the graph,
Teacher, it's decreasing acceleration, decreasing deceleration, then constant velocity.
Come again, your question, Marcus.
The whole thing is decreasing acceleration, then decreasing deceleration, right?
Yes. Here, because at the beginning, the velocity increase actually more faster. You see the gradient bigger, this gradient smaller. So meaning that here velocity higher, actually here velocity become lesser. Not lesser lah. The gradient become lesser. Okay, I should say gradient. Gradient here is big, the gradient here small. So the gradient showing the acceleration. So here acceleration high, here the acceleration less. So this is decreasing acceleration. And then here is deceleration because velocity getting smaller, so it's decelerate. Okay, okay, now the what question? What is a position when he opens the parachute? At which point he opened the parachute? Andrew, at which point the boys open his parachute? STUVW.
Oh, just simple. My answer very simple.
Yeah.
My answer is the same as your answer. Okay, what's your answer? You. Okay, you.
I'm asking you the answer.
Okay, answer is you.
Yes, correct. The answer is you. You lah. Okay, correct. At this point lah. Okay, now they ask you to explain why you choose you. Andrew, since you give the answer you, can you explain why you choose you? SPM question, no. First one very simple lah. You see you. Second one they ask you to explain why you choose you.
Because the velocity of the skydiver is decreasing.
Yes, come again.
Because the velocity of the skydiver is decreasing.
Yes, correct. That is the point where the velocity of the boy started to decline, started to decrease, right? Okay, so the answer is velocity decreases abruptly at this point. Suddenly decrease, right? The velocity. So we say it's a point where the velocity decreases abruptly. So this is a place where the parachute open. Okay, next. Calculate the accelerations of the skydiver. How to find the acceleration of skydiver? ST from here to here only. S to T. So how to find the acceleration? Okay, we can only estimate only because this is not a strict line, you know. So we use this formula law, okay, final velocity minus initial over the time. So final velocity is over here lah, s to t, so it's 30. Initial velocity is 0. The time taken was 3 seconds. Correct, not? This is the curve. Curve we cannot find gradient, or so don't find gradient. Use the formula lah. Final velocity minus initial divided by the time. Final is 30, initial 0, time taken 3 seconds. So you get 10 meters per second square, which is correct lah. Because gravity is very close to 10 meters per second square, correct not? Okay. All right, next. You understand or not? All these many people very quiet, they want to get quiet one. Let me call them, ask a while, see whether I understand or not. Tan Si Ming, okay? Diu Si Ming, sorry. Diu Si Ming.
Okay.
Okay. Okay means what? Understand. Wang Hui Ni, okay?
Okay.
Okay. Xavier. This boy, I know him now. Xavier, are you there?
Understand.
Understand, Xavier? Xavier pass up works, okay,
I got pass up.
Yeah, I know. I never say you never pass up. I saw your file. When I checked, I saw your name, Xavier, okay? All right. Okay, next question. In the space below, sketch a graph acceleration time for motions of the skydiver at the position STUVW. This is a difficult question. When I mark the SPM paper that year's high, 10 students I marked, so 10 of them all wrong one. Okay. 10 students, meaning almost all the candidates in that center got it wrong. Okay. That means you know how difficult the question, right? Sketch a acceleration time graph. Okay, you see, now I want you to think, this is velocity time. They want you to change to acceleration time. From velocity, change to acceleration time. Okay, time, okay, you can just copy the time. Time means you divide into a few stages, S, T, U, V, W. You can just follow the time here, no problem. Only here you need to calculate the acceleration. But to calculate acceleration is impossible because this is a curve, right? A curve, we cannot find a gradient. In your syllabus, you haven't learned how to find gradient of curve, unless you learn later on in additional maths. In MX, you find dy dx. I'm MX teacher, actually.
So teacher,
I thought MX are longer than teaching physics,
do we need to use differentiation in solving physics?
No.
Right. Okay. Luckily.
No, because the ministry make the decision. He say don't accept differentiation dy dx in physics, because they claim some students they never learn MX, but they take physics one. It's not fair to them. They say.
Okay.
Okay. All right. Okay. Now, so how to give answer? Okay, I want to ask your opinion now. Here, actually, what happened here from here to here? In your opinion, like just now, Marcus already said, from here to here, what happened to the acceleration?
Decrease.
Decrease, correct not? Here to here, the acceleration is decreasing. What about here?
Also decreasing the acceleration.
But this is deceleration, correct not? Decreasing now. And finally here?
No acceleration.
Yes, very good. So that means you know how to sketch the graph already lah. This John give one answer. He say what is differentiation? From 5, your dy dx you haven't learned. Have you all learned dy dx or not? I think not yet. Like dy dx is from 5 second semester, right?
You mean the
from 4 learn already, right? Differentiation, correct not? Dy dx.
equations? Find d, then find x.
dy
What does
dx
x equal to?
Differentiation Form 4 you learn. Form 5 you learn integration. mx Form 4 you should learn dy dx
Oh, differentiation isn't the minus like 2 minus 1 the difference between 2 and 1 differentiation
differentiation means you find dy dx lah. Okay lah,
Oh,
dy dx
okay,
lah.
never mind.
Then Form 5 you learn integration. Two very big topic in your addition math. Okay. Okay, now the answer like that. So here, that's just how we say the acceleration decreasing from st to u. The acceleration decreasing now. Okay, acceleration decreasing. And here, apa salah? Sakit. Dia ada tengah hari nanti dia balik lah sebab ada soalan simpan dekat situ kan petang nanti. Okay. Okay, do you understand the graph or not?
Teacher.
Okay, here positive lah, acceleration decreasing. Then from u to v, right? Just now we say deceleration also decreasing. So you put it under negative lah, decreasing. Here lah, actually the deceleration is bigger, bigger getting smaller, then becomes 0. Finally, acceleration 0. When velocity becomes stable, so the acceleration is 0 lah. So the graph look like this, okay?
Teacher, the lines are straight lines or curve?
Curve. This one should be a curve. This one also should be a curve lah. Only this one straight line, okay? Okay. Teo Si Ming, understand?
Yes, sir.
Yes, sir. And last question. Suggest a way how the skydiver. Okay, I show you the answer already lah. A way how the skydiver landing to avoid sustaining bodily injury. So bend his knee during landing. You all know, right? Or don't know yet, or you're from 4 only. From 4, I think you have impulsive force, you haven't learned, isn't it? Okay, come, let me explain a little bit. From 4, I think you haven't learned. Say Marcus say don't know. Okay, during landing, right, you have to bend your knee or no? Okay, impulsive force means it's a force occur suddenly during an impact or collision. When you are jumping down, right, the moment your leg touching the ground, that is considered impact, So during that short times of impact, right, there will be a very big force produced. So this kind of force is called impulsive force lah. It's a force occur suddenly during an impact or collision. Okay, how to reduce this force to avoid from injury? So he bend his leg lah. Bend his knee lah, not leg. The leg cannot be bent one, so bend only the knee. Understand? Why by bending the knee can reduce the force? Okay, like this. You see, when you are jumping down, when touching the ground, so you bend slightly your knee, then you stand up again. Okay, by doing so, bending your knee, right, during landing, you are extending the impact time. You make the time of impact between your leg and the ground longer because like a little bit elastic, because when you are landing, you bend your knee, then you stand up. So you make the impact time longer. When the impact time become longer, right, during the collision, when the collision time or impact time longer, the impulsive force will become smaller. Later on, you will learn this in chapter 2. In this chapter also, Okay, in this chapter, you will learn that. When come to the time, I will explain in detail why by extending the time, the impulsive force becomes smaller. Okay, another good example I want to ask you all for design a car. Have you ever seen this F1 racing, F1 car? Those F1 car are very hard or soft one. Can you tell me? You watch in the television, you see the F1 car. They accelerate in very high speed. The body is soft or hard? Joel, the F1, the Formula 1 car.
Body of the car.
Yes, hard or soft?
Soft core.
Soft. They are soft. You know why they design the car soft? Okay, the reason is
absorb impact.
Very compact.
Same concept. The body soft, I mean during collision, soft and soft, they will crumble slowly. Gamet, in Basel, you say gamet, when you crumble, because their body soft, right? So they will crumble slowly. Then it will make the impact time longer. The purpose of design that kind of car soft, right, is to lengthen or to increase the impact time if collision happen. So by extending the impact time, they can reduce the impulsive force. That is the reason, you know. So actually, when you go and buy a car, right, the bonnet, the car should be soft. No, soft is better. No, you don't buy a car very hard one. Very hard one during collision, a lot of people die one. Okay, if the body front part is soft, right, actually it's good, you know. Soft means when you collide, so it will crumble slowly. So it takes longer time, you extend the time. Okay, in the SPM essay question, they like to ask this kind of question one. They ask you to design a car. The car which is very safe and it can run very fast. 10 marks question, essay question, you know. Okay, we come to it later. So in this case, they say, bend his knee during landing. The reason is, increase the impact time to decrease the impulsive force. Okay, that is the purpose to make the impact time longer so that impulsive force becomes smaller. Now you just accept the answer first. Okay, when come to I think lesson 6 or 7, you will learn impulsive force. Okay. So okay, got it.
Yeah.
Join, okay, understand?
Why is the acceleration time graph drawn in curves instead of a straight line?
Because you are not sure this acceleration decreases constantly or not. We are not sure, We are not sure, so it's better to put it in a curve line. If you draw this line become a straight line, means you are very sure, you know, the acceleration decreasing constantly, decreasing linearly. But here we are not sure. We are not sure unless you go and calculate the gradient, then the gradient decreases constantly. But here we are not sure. We are not sure that the decrease of the acceleration is constant or not. So we don't use a straight line, use a curve. Okay?
Okay,
yeah.
Thank you.
Okay. All right, so we have finished this. Okay, still got 2-3 minutes. So I want to start lesson 4. Okay, lesson 4, you have the paper with you or not? Did I share the paper with you already? Marcus?
Not yet.
Not yet. Okay, I share with you all now. Okay, this paper, inertia. Why you always don't have one? Are you?
You send us the photogate and electronic time system.
Oh, yeah. In that case, I want to discuss the one finish first. I don't want to hold back this one first. Yeah, you know why I send you the photogate thing, you know, because it's important. Okay, come now. This is something to do with you all. Okay. Photogates and electronic timer. You all have the paper, right? You know why suddenly I sent this one to you all? Because you guys are going to sit for practical test in the SPM one, you know. So the practical parts become very, very important, the hands-on practical. Okay, I check in your syllabus, there's one segment they put there. determine acceleration using photogate. Okay, and also determine the acceleration of gravity using photogate. So photogate become very important. Okay, come, let's look at the paper. What is photogate? Okay, a photogate consists of infrared transmitter, meaning that here got transmitter. Transmitter means the one who send out the infrared. Infrared is types of wave, you know. Okay, let me tell you what is infrared. In your house, you got one, your remote control to on off the television. You can see a red light. Correct? Now, when you on the television, you press. There's a bulb red color one. That one is infrared lah. Okay. So this transmitter will send out the infrared and then to be received by the receiver. So from here send to here lah. So actually now the infrared was sent out by the transmitter and received by the receiver in very, very high speed, very fast. Okay, nanti okay. All right. So this thing can use to record the time. Then connect to a timer. You see, not electronic timer. This is the timer to record the time lah. Okay. Infrared transmitter receiver mounted in a frame with a gap between the rod. Okay, here got gap. A photogate together with an electronic timer. I mean the whole set of things to have this photogate and this electronic timer, they have to connect together to work together lah. Okay. Measure the time interval of object blocking the light beam. Okay, you see now. I put a trolley. This trolley carry a cart. When a trolley cross over, right? When I push the trolley cross over, the cart will block the infrared, correct? Not? Let's say the trolley, this one I lower down So when I push the trolley crossover, so this cart will block the infrared. Okay. Once the infrared is blocked, right, it will start to take the time already, record the time. The timer will record the time. So meaning that actually the electronic timer can record the time for the trolley to move from here to here, the distance of the cut. Because only the cut blocking the infrared. So for the time taken for the trolley to move, this distance can be recorded. Okay, it's very, very accurate one. Okay, you see now, wait. The measure the time interval of object blocking the light beam. This cardboard used to block the light here. Object passes between the transmitter and the receiver. The time interval will display on the screen. Okay, so the time. So meaning that this photogate purpose is to record the time for the trolley to move this distance, the distance of the cut. Okay. So comparing the other time, you learn this ticker tip. Ticker tip, you need to minus one tick. You remember the formula or not? A minus V minus U divided by T. The time have to minus one tick. They were not accurate, you know. When you are using this photogate means the time, we don't need to minus anymore. No need minus one because this one can record the time very accurate. Okay, I want to finish this one first. To measure the average velocity, okay, what you do is to measure the average velocity, right? So you let this trolley go through the photogate. So this distance of the cardboard is recorded. Okay, and when the trolley passes through the photogate, right, the time will be recorded. Okay, the cut break the beam, the cut block the infrared, and the timer will show the time. The timer is connected to an electronic timer, isn't it? Okay, so the length of the cut D is measured. You measure the distance D, and the time recorded by the timer. So the velocity straight away you can calculate, just take distance divided by time. So initial velocity, final velocity, you can just calculate like that. Taking the time of the distance of the cardboard, which pass through the photogate, right? And take the time recorded by the electronic timer. So you just calculate the velocity. Okay, and then this, the one later, I think I stop here. Time's up already. I think you got another lesson. Okay, lah. So for science one, I have to stop here. Actually, I got a lot of things to explain, but the time not enough. I have to stop here for today. So I will explain to you further next lesson for science one. Okay?
Okay.
So what lesson you have now?
No moral.
Moral. Okay, I better let you go. Okay. So I see you on Thursday again. Okay, for science one. Okay, bye-bye for science one.
Okay, thank you, sir.
Okay, bye-bye, everyone. Bye-bye.
Thank you, teacher.
Okay, bye-bye. Bye-bye.